Hello everyone, I'm Tor Iveroth. I work with SolidWorks Technical Support, mainly with Enterprise PDM. And today we're going to talk a little about SQL Server performance consideration, since Enterprise PDM is heavily reliant on SQL Server. So yeah, let's get started. It's fairly high level, we're not going to go in and start writing SQL queries and stuff. So it's more of an overview, considerations when deploying, installing, upgrading to a new SQL server, what you should think of, what you should avoid, some general recommendations from SolidWorks when it comes to managing your SQL server. Let's see. Nope, not working. Click. There. Maybe I need to hold it somewhere. There we go. Okay. So, SQL Server, or SQL Server as many call it, that's the component that hosts the databases that makes up Enterprise PDM. And when we're dealing with SQL, it can be kind of tricky to get it running smoothly, as we're going to see in this session. And often when it comes to performance, anything dealing with speed in an EPDM world is usually reliant on that SQL server, because that's the brain of EPDM. It contains all the good stuff that you see when you work inside the EPDM file vault. Okay, so we're going to go over just a brief thing, what EPDM and SQL has to do with one another. Talk a bunch of SQL Server considerations, in particular for where you want to install and set up your SQL Server. You may have an existing one, you may want to tweak it a bit, you may want to set up prepare for a new server, so that's good. And once we got the server up and running, maintenance, keeping that server happy, keeping it going, how to monitor it for issues, and some words about virtualization. Okay, so let's see. Yep, SQL, heart of Enterprise, so it's the brain of Enterprise. We have an archive server part that stores all the physical files and stuff, but that's basically a file store. So the SQL Server contains all the logic, all the permissions, all the names and versions and all that stuff. And anytime the SQL Server is affected, it usually affects the whole company, everyone, because everyone is talking to that SQL Server database. Every single component in EPDM will communicate with this central SQL Server. Even the server, the file server, the archive server will talk to this SQL server, as well as the clients and perhaps the web server. So it's very important to make sure the system running SQL Server is configured correctly and given a lot of priority. Okay, this is a silly overview over what it is, but if I don't know, the blue lines show database traffic, and it's to symbolize that everything is talking to that SQL server over to the left, including archive server, web server. Everything goes back to that upper left SQL server, or database server, many calls it. Okay, so let's talk a little about the SQL server. All right. SQL Server, it's more than just an Office application or a little notepad or something. There's a lot of stuff going on behind it. They explain it in various layers that does various components in SQL Server. So the fancy words are they have the execution layer that actually does most of the queries and stuff, all the piece of code that's running and returning information and stuff like that. And there is a layer for the storage, because all that information needs to be stored somewhere in a database file. So all the input, output, I/O is done by the storage layer. and then the actual operating system layer, which is the interface, the service, the SQL Server part of it. So there's a lot of things that have to work together and has to be happy to work together. Let's see. Okay. The databases that are stored inside SQL Server, we call them a relational database. An enterprise PDM is a relational database application. So it's a database, it contains a bunch of tables, and that's what we see there. If you've never seen inside an enterprise database or any SQL database, it stores information in all these tables or Excel sheets essentially, where all the information and all of those tables have some kind of identifier that then link it to other tables. So there's a lot of stuff happening behind the scenes. And when you go into the managing studio of SQL, you're going to see all these tables that pop up. And the names of the tables are usually what type of information is stored in them. So the earlier table, first tables are archive server information, and I don't know how many tables there are, but there are tons of them. Okay, and this is the maintenance tool or the management tool of SQL Server when you need to go in and tinker with it, and you likely will, either if you're implementing EPDM or managing or maintaining EPDM. The SQL Management Studio is your friend as an administrator or a database administrator. And this is how it usually looks. You have all the tables to your left. You can see the content of each table in the big area and some information about it. So we're looking at the documents table. That's kind of the brain table where all the files are given an ID and information about them. Now, SQL Server, besides having the enterprise part, the enterprise database that contains all your vault information and stuff, there's also a bunch of extra databases running on the SQL Server, and those shouldn't be, you should be aware that they are there because they could affect your overall performance here. There's the master database, which will exist as soon as you install a new SQL Server, bam, it's going to be a master database. The master database contains essentially your logons, the SQL administrator password and stuff like that, and little information about how the server is configured and stuff. The master database is it's not really doing much with the master database, so it can just hang around on its own. MSDB is a kind of a helper database. It contains jobs, maintenance plans, things like that. That's where those things are stored. The model database, again, it's just one of those helper databases. It's not really actively used when the SQL Server is running. If you create a new custom database, it uses the model as kind of the template database. TempDB, however, that's a very, very important database. That's the temporary DB that the SQL Server uses. Any kind of calculation where it has to start setting up temporary tables to figure out what result to give down to the client will happen in that TempDB. It's actually more access than the actual normal Vault database, the database that you store all your documents and stuff. And a lot of times that TempDB can be the bottleneck when it comes to getting your SQL Server running smoothly. Now, none of these databases, if you're dealing with backups and stuff, they don't really need to be backup unless you're adding some custom stuff in these databases. But when you install a new SQL Server, they will be created. The TempDB, for example, it lives temporarily. When you reboot a server, it starts over. Now, all the information in each database will have to be stored somewhere in the physical file, and this is where you're going to manage your database files for performance reasons and stuff. So they are usually stored in a bunch of different files there, and the database is usually called with a name, and we're going to look over each of these files here. So there we see an example of couple of MSDB, TempDB, PDMWE, that seems to be a file vault. And SQL Server uses 3 types of files. The primary database files, that's where all your information in the vault is stored. And they are usually called MDF files. There's secondary data files, and that becomes a little tricky because you can actually store objects in secondary files. You could actually take a table and move it over and store that in a dedicated file. But that is, I rarely see anyone really doing it, and it can be really tricky to maintain. So I would not, I would avoid it unless you really need it. And then the transaction log. The transaction log is where all the operations that's done into the database are written so that it can roll back and keep track of all the changes. So normally you will see the primary database file, the MDF file, and the log file. Every file vault will have one database and one MDF file. That's the important file. That's the file that needs to when you back up something or when the SQL Server backs up something, that's the file. That's also the file that it contains all the core data. So that's the most important file. Now the MDF file, the secondary data file, as I said, you could actually use it. Few people do it, but you could use it to store individual objects or tables to it. Potentially splitting up your database and putting these secondary files on separate drives for faster access. But it does require a lot of maintenance and essentially a database administrator to get that running smoothly. And the LDF file. So MDF and LDF, I think keep those in mind. And the LDF file contains all the information. It uses it when recovering the database or when something goes wrong and it has to roll back and undo its changes. It's usually called LDF. The SQL Server uses something called write-ahead login, WAL, to make sure that it never loses any data. It always keeps backups and backups when it writes the data, because once it ends up in the MDF file, in the database file, you don't want anything to go wrong there, any garbage coming in. And the bottom thing is MDF and NDF file, the primary and secondary database file, those are SQL Server will access them at the same time and read stuff from them. The log files are just works with one at a time. You can actually split up the log files over multiple disks as well to make it even more efficient. This is the write-ahead logic. Basically, something happens on a client. I need to add some data, fill in a data card or some information. So it goes first into the RAM, and the SQL Server stores it in the memory to begin with, the RAM, the buffer cache they call it sometimes. And then it writes it in that transaction log, and then finally it writes it to the MDF file, to the physical thing. So really that's the 3-step process. So the SQL Server memory, transaction log, and physical log. So some considerations for your SQL Server. What to consider when we're dealing with it. Of course, the components that make up the system that runs the SQL Server is extremely important, right? And there are these things, dedicated hardware, we're going to talk about that, the operating system that actually runs the SQL, the CPU, the brain of the computer, the memory. Memory is so important in SQL Server, where those database files are stored and how it communicates with components on the network. Our recommendation, whenever possible, have a dedicated SQL Server. And dedicated, I mean, that's the only job it has, to host those databases, nothing else. It shouldn't be a domain server. It shouldn't be Ideally, it shouldn't even run the archive server if possible. It may not be possible, but as a first recommendation, make it dedicated so that the operating system can focus on it. Yep.
So when you say dedicated, are you saying database server with one database? Or can you
Well, actually, we're going to see that. Actually, ideally, yeah, one database per SQL server. But, and normally you have perhaps one vault, maybe 2 vaults. So I don't think you would actually set up a dedicated vault-based SQL server. But, huh? Well, yeah, we're going to see. It's actually using, all these vaults are going to share that memory, those resources, essentially. Even while they might not be actively being used, if they take up a lot of RAM, a lot of cache into the memory, they could actually affect the active vault, the main vault. So I'll show you in a slide, but basically we recommend, if you have test databases or sandboxes or development vault or whatever other machine, don't use it on the production machine, because it's using up some of that valuable memory resource that it is. And it's very difficult. You can't really tell SQL Server only use all the memory for, use 90% of memory for this database, but not for these, because SQL Server keeps figuring out that on its own. You first.
So virtual machines then, having virtual servers under one server, you're saying avoid it completely?
I'm strongly against it. I mean, I think virtual machines are awesome when it comes to testing, to hosting kind of non-intrusive applications or server applications. The archive server, for example, that's just a service that reads and writes stuff to the disk. It doesn't really need that much of a horsepower. SQL Server, I keep on pointing to that later. SQL Server, when you're running virtual servers, while the technology is great and everyone is saying it's great, it is actually, you're adding so many layers of overhead when you're dealing with virtualization. You have to have the computer that runs the virtual host. You have to have the virtual software, if it's VMware or Microsoft Virtual Server, so that's an operating system of its own. And then you have to install an operating system within the host application. And then you have to install an SQL operating system within that. So you're already 4 layers down when you get to the actual SQL server. And, since it's easy, that virtual host will also have, you set up a few other machines, they're still sharing the same core resource, right? So it's not really dedicated in that sense. It's actually one machine that's doing a lot of stuff at the same time, eating up valuable, good CPU and memory that the SQL server. So if you can avoid virtual, while it's easy to manage, avoid it. Yep.
I have many customers
Yeah.
asking regarding virtual and regarding having hosting involved in an existing SQL that, for instance, uses their ERP system. And I don't recommend them. I tell them we don't recommend
Wait.
it's not good, but the bottom line, how strongly should they
You should be very strongly, very firm. Say Tor said no. It's that's the thing. No, the thing is, yeah, it's easy because you don't have to buy an extra server, and let's just use the one we have. Let's just let them run parallel. But it's like juggling balls, right? It's easy to one, but the more you do, the more it kind of goes to pieces. Of course. Every darn vault is going to be unique and have its individual challenges. So it's very hard to compare vault to vault and say, this customer or this vault works great in this and ever. So that should work great as well. But it might not. It might be completely different depending on how the vault is used. Yeah. A little. I'm not going to say which server machine to add, but what to consider for the hardware when it comes to that. So we get to that. Yeah. So let's. Was there anything else?
Just in Philips, we contract with T-Systems to manage our server for us. We have servers at the data center, and we do it somehow with virtual servers, but they have dedicated hardware.
Yeah, well, it's still running under a virtual environment. It's still from an IT standpoint, virtualization is great. But SQL Server is real finicky when it comes to, real picky when it comes to getting all at once. It's very selfish in that way. You know, it wants everything. So so whenever possible, you'll have most success with a dedicated server not running on a virtual machine. Yes? Well, because of security. You don't want people going in and deleting tables and stuff. So just, you know, if you're going to have remote access from other offices, first of all, you probably would have a WAN, a wide area network with the secure VPN hardware or lines directly in. But, you know, it is, of course, possible to just open up that SQL server, just a port, open it to the internet, and you can sit at home and connect it. But that can be, of course, dangerous if that port gets attacked, and especially SQL Server. It's such a wide used product out there, so every hacker will attack that darn SQL Server as soon as it can, as soon as you open it up. So it can be dangerous, especially if you want to store something that's, you know, proprietary, your own company data. You don't want to have that, sure.
Yeah. How about SQL Server cluster services?
Again, it's one of those, yeah, there is a lot of cool technology out there to maintain and manage and cluster it and stuff like that. From the official SolidWorks standpoint, we can't really officially support it because there's so many combinations, and that's the same stance we have on virtual. Now, that's the official slash, but I still think virtual is not good. Cluster, yeah, that's as a failover mechanism, perfect. As a way of making sure you have a mirrored environment or something, perfect. It does require a bit of work, right? It's not something that you just click next, done. You have to actually prepare. You have to have like a triad server set up, and you have to have a dedicated thing, you know. And of course, from an IT standpoint, well, let's just do it with a bunch of virtual servers. But they're still using the same physical hardware. You know, it's the same memory that's just shared now between a bunch of silly operating systems. So I think virtualization, no. Cluster, sure. We can't really say that this is exactly how you do it. We can give you some recommendations and stuff, but if you have the manpower to maintain it, sure. Yeah. Okay, so what do you need to think of on the machine then? Whether it's that virtual machine or that dedicated physical box in the server room, right? What operating systems? What's 32, 64-bit? What to think of with the CPU, RAM, storage, and network? Same stuff we talked about. Operating systems, you know, SQL Server really runs on anything Windows-based. APDM, at least the releases that's been around for the past 4 years or something, that's SQL 2005 and higher, okay? So the current SQL versions is 2005, 2008, 2008 R2, which is a kind of revised 2008. I would say 2008 R2 is a good platform to go to. There is a newer SQL called SQL 2012. We are not officially supporting it yet. Okay, so we're not distributing that. When you buy a new EPDM package or something, you're not going to get SQL 2012 yet. They're still, you know, verifying it within QA and within tech support. I practically don't foresee any issues with SQL 2012. It's very backwards compatible, just like SQL 2008 and 2005 was backwards compatible. They're not forwards compatible though. So if you are having a machine there where you install SQL 2012 for some reason, and you take a backup and you need to move it to an older SQL, bam, you can't. You cannot restore something that's newer. Or when tech support gets involved and you send them a backup of SQL 2012, we might not be there yet. But it's coming. Okay. Windows, Vista, and 7, 8 for testing only, not for production use. Don't use a workstation operating system to host your important SQL server. That's just silly. Windows Server 2012, again, the official support is in the pipeline, but you know, I don't foresee any issues. What they have done in 2012, though, and Windows 8, if you like that, they have dropped the support. You can't install SQL 2005 on Windows 8 or Windows Server 2012. 32 versus 64-bit, and why even mention it? I would say, if you even hear the word 32-bit in an SQL, when you're planning to install an SQL server or host an enterprise PDM vault, I would run away screaming, because it's kind of silly. 32-bit is a old technology by now. There's so many restrictions, and the main thing is the memory, and SQL Server loves memory, right? As 32-bit can essentially, they call it the virtual address space, the VAS. That's the memory that an application can actually use. But as soon as you start up Windows has eaten up half of that, right? You can use a little switch to get a tiny bit more, the 3 gigabyte switch and stuff. It's still ridiculous. You can pop in as much memory as you want in that SQL server. I mean, in that physical hardware that runs that 32-bit server, you're still not going to use that memory. It's just stupid. Now, 64-bit systems, it jumps from 4 gigs to 8 terabytes of available space. So that's quite a bit of difference. There's no real upper limit when it comes to 64-bit systems. 64-bit can utilize a heck of a lot more memory. It can utilize all that memory that you put in the machine that hasn't been eaten up by your virtual host and your other stuff that you run on it. And you can, I don't think you can even install 32, at least not the later versions of SQL Server. SQL Server 2008 R2 does not even come in a 32-bit version, right? Yep. Yeah, we actually added that support in 2012. Yeah, that was the EPDM component that couldn't be installed physically on it. You had to have a separate machine, which was silly. But now you can, if you really want to. Exactly. So yeah, if anything comes out of this, 64-bit is the way to go. And SQL 64-bit. The SQL 2008 R2 does not come in 32-bit. CPU, well, CPU, what's important there is that it needs to have a lot of CPU power and a lot of cores so that it can multitask, so it can do stuff at the same time, right? So you can have, and SQL Server uses, you can have a single physical CPU with a bunch of cores in it, or hyper-threaded stuff, or 2 physical CPUs, but focus on getting a lot of those cores, because SQL Server is utilizing that behind the scenes. I mean, the more cores, the better it can manage all that thinking power. It does. I mean, then it all depends on how you write an SQL query, because no matter how many cores you have, if you write a select from somewhere, you're still only going to use, it's still going to be, it all depends on how your queries are written, if it's going to utilize it. But the SQL Server decides what it thinks is best. That's the thing. The SQL Server tries to be mind read and figure out. But, and it's tricky to write questions that's asking for one little result from one table. It's kind of impossible to write it in a multi-threaded scenario. You're just going to get one response. So it all depends on what queries are running when and stuff. But it does use cores, and you want to have a bunch of cores. What did I mean by that?
So if it gets a bunch of requests at the same time, it'll spread them.
Yeah, I will try. Exactly. And if you have 2 vaults or something, 2 databases, it's going to be happier than having one. So anything, the cores helps with the multi-threading part, doing the same stuff at the same time, parallel. Now, of course, when it comes to actually speed of your CPU, faster, better. That's how it is. If you can get it faster, get it faster. There's no difference. I mean, nothing. It's just logic, I think. Memory is the most thing. Besides, the CPU power, you don't want to run it on an old Pentium machine or something. Get some kind of fairly modern CPU technology with a bunch of cores and stuff. But memory, that is where everything is happening. Because what SQL Server does is it does everything in memory first, before it even goes down to disk and fiddles around. And anything involving writing to a disk, regardless how fast that disk is going to be slower than the RAM, than the memory. The more RAM, logically, hopefully, depending on the RAM, the better the SQL Server will be. It uses it for any kind of calculations and anything that's happening. And as soon as SQL Server gets a request from PDM to do something or from a client, it first tries to use whatever is in the RAM before it starts going and grab stuff from disk and stuff. And as a guideline, it's difficult to do that, but what many recommend is that have as much RAM as the size of your database. That way you can keep everything in memory without having to actually read and write. Now, of course, when we're talking, if the database has grown to 480 gig, it might be tricky. But you know, if you are getting a new machine or something, get a lot of RAM to it. And if your database is, 4, 5, 10 gigs, get at least that much RAM so that it can keep it. Plus a little extra for the operating system and the other stuff, the virtual stuff that you're running and stuff. If you're buying a new server, don't fill all the memory banks with the memory chips. You could pop in a few more memory banks down the road as the database grows, if possible. And RAM is fairly inexpensive in the whole thing. So again, there are some memory settings, and there's actually one setting that we recommend heavily to enable, and that's the max memory setting. When SQL Server is installed, it's going to start eating up all that memory, and it's going to eat up all the memory that Windows is using, and that anything else is using until it's happy. Now that can cause problems, because if it starts using Windows memory, Windows will start caching and reading and writing stuff from the disk. And as soon as you start doing stuff from the disk, things are going to get slower, and you're going to end up with bottlenecks. A lot of activity there, back and forth. So you want to make sure that it's taking as much memory as possible, but not all of it. Leave a little for the operating system. And there is a setting. Let's see what time it is. There is a setting that's inside the. Darn, time is just flying. Let's do it. A little video. Ta-da. And this setting is, kind of disabled by default. So I think this is a good first place, especially if you have a server. Oh, great. I can't even play my fancy videos. Okay, no videos. I'll just explain it. Anyway, inside SQL Management Studio, when your database is set up, when the SQL Server is set up, you can right-click on the server and select Properties. There's a page about memory, and there's this thing called Max Memory Setting, and it's disabled by default. It's going to use whatever memory you can grab, right? And that's fine for a while. And as your server is running there for a week or two, all of a sudden things are going downwards. Right? That could be an indication that it's eaten up as all the good memory. And now Windows starts caching. Now things is basically using up resources that the operating system or the virtual machine or whatever needs to actually be happy and run. So if you have a lot of memory in it, go in and check that setting. It actually can help a lot. And set it so that it leaves enough memory for the operating system, 2 gig at least, and then for whatever other services are running on that SQL server, there may be other things that's needing a bit of memory. So that's a strong recommendation, something to check. This is what we talked about earlier, that the more databases you have, the more memory it will share. There are some, you can Google it or something to see how big is my database in memory. How many megabytes does it take? You can see every database will actually use up some memory resources. So the more databases you have, the more likelihood it is that your primary machine, primary Vault database will get not as much memory as it should get. So if use your dedicated server, have your Vault on that dedicated server for sandbox testing, for develop, for other stuff, you know, use a workstation or something that doesn't need all that horsepower. Physical versus logical. That's another term. That physical is essentially your disk. Logical is your memory, your RAM, right? And you want to, if ever anything possible, you want to use RAM over disk whenever possible. RAM first, disk later, which is, if you have a lot of RAM, SQL Server will be happier. Right? Once it fills up and can't hold stuff in RAM or doesn't cache that information in RAM, it starts reading from disk, and that's going to be a little slower. So, just an overview again. It is, remember that there are other things running on the server. SQL will eat up all the memory, and there will be sharing issues with that memory. You want to give as much memory as possible for the SQL server, but not take it away from your operating system. And when performance hits, when things are going down, especially if it gradually goes down, you know, if it just, you know, starts fine when you reboot the server and then slowly goes worse, because it's actually starting to fill up and eat up memory and perhaps start, you know, reading and writing to fragmented disks and whatever. Yep. Well, you know, yesterday I right-clicked on a folder and it just came up instantly, my right-click menu. Today I right-click and I wait a few seconds before. You feel that thing, you know, you feel it just feels sluggish, right? Because the SQL Server is hard at work doing the stuff. No. That's okay. But, you know, of course, there could be bugs in EPDM, certain operations that run slow. You know, change state is horrible, but everything else is okay. It's probably an issue with some kind of combination of the files or whatever. But if everything is just horribly slow, and there aren't any obvious network issues or anything, then I would say memory or potentially disk is the issue. Going to the disk then, right? Now, memory, it's going to use that first, but yeah.
Sorry, just go back to that. You have added in SolidWorks and you allow as templates, would that show up there too as being slow?
Yeah, I mean, if it's reading a lot or needing a lot of information from the SQL server, which it will. Anything you do in EPDM, as long as you're online, will want to ask the database for something, and if the database is sluggish, your whole thing will be sluggish. Yeah. So storage can be, that's another thing that you shouldn't overlook. While the memory is the primary thing and the CPU is the primary thing, it still has to physically write to that transaction log, to that MDF file. It has to read from those logs. On top of it, it has to read and write from that temp DB. And that is another key aspect. When you just install SQL Server, everything is going to end up on the same drive, essentially, on the same location, unless you specifically tell it, put my database file here. But they're all going to end up on the same drive, same location, sharing all that disk. And how can we speed up the disk then? Well, first of all, preferably direct attached storage, i.e. hard drives that are, or spindles, things that are attached straight to the server, to the host machine, to the hardware. That's much faster than getting, using a SAN device or a NAS device. Well, SQL Server, you shouldn't even consider anything on a share when it comes to SQL Server. While the newer SQL Server versions it is possible to actually store the database files on a network share, a UNC path and stuff. It does require a bit of tinkering to do it. And imagine it now has to start reading and writing over the network, and it's just horrible. Don't do that. And that's just silly. Get a good hard drive or a bunch of hard drives. Now, different hard drives will, of course, act differently, and RAID is the thing that makes hard drives apart. RAID for redundancy, for mirroring information that's written to one disk is also written to the second. And there's tons of different RAID levels, right? And some are better, some are worse. But keep in mind that if you're investigating or deciding on a drive, and especially on a RAID array or something, be careful there. Do some investigation and see, for example, the database, the faster it can read, the happier it will be. So select a RAID level that gives good read access. Now the temp DB, a lot of writing is happening. We write to the database, to the MDF file, but SQL Server uses that temp DB, the temporary database, to read and write information constantly. It's basically using it as extra cache, extra memory. So as we will see here, the best way to configure your server is actually to put the log files on one drive, the database file on one drive, the temp DB on one drive. So they're all split up. They're essentially given their own dedicated drive instead of one single drive where Windows and Microsoft SQL Server has to read and write and jump all over the disk to get that information. And when we say drive, we actually mean individual drive, not a partition of a big drive. Not just a part. You can partition it in C drive, D drive, E drive. It's still the same physical disk in the bottom. That's not going to help you at all. So it needs to be its own spindle, its own drive. Yes? Yeah. The MDF is the one we talked about. That's where the data are. And then the LDF, that's the transaction log. All the information it's rating to the transaction log first and then to the MDF file. But why you want to split it, if possible, is that, like anything, if you have 3 files on the same drive, when the operating system or an SQL will start, jumping all over to find that information. If it can get it from separate drives, it basically will read information or write information much smoother, much faster. The temp DB, that's the other one. And often many people forget about the temp DB. The temp DB usually ends up on your Windows drive. You put your database files on a different drive. You put your MDF and LDF, but that temp DB is still hanging over there on the Windows drive, where Windows is also sharing and reading and running the programs and stuff. So now you have a share issue there. So you can actually gain a heck of a lot of improvement by putting the temp DB on its own dedicated fast drive, if possible. Yeah.
So if we're separating the archive server from the DB
Uh-huh.
server, what would you recommend for size limitations with this DB?
Well, the database never grows that much. I mean, if they can be, an archive or can be, hundreds and hundreds of gigabytes, right? A database are in the ranges of, 1 to 10 gig or something, maybe 20 at the most. I really haven't seen anything. There's a lot of empty space in the database files and stuff, so they usually take up more space on disk than actual content in it. But you won't reach that high of a limit when it comes to database files. 100 gig drive is often enough for the database, especially since you're splitting them over to separate drives. You don't have to have that big of a hard drive. You would have to have it if you have a bunch of databases and a bunch of temp DBs and log files and everything on one single drive, right? But if you do split them up, then you would not need that big of a drive. Faster is probably better than bigger. Exactly. I mean, it all depends on what you cram into that vault and stuff. But they range somewhere around there. Some vaults can be just a few gigs, maybe 10. The bigger vaults are usually 10, 15, somewhere around there. So it's not that, and that's from years and years of data. Yep. Yeah, essentially, that's the database file. There's always going to be this transaction log that sometimes can swell a lot, and that's our other recommendation, right? It all depends. The transaction log is very, very important to SQL, right? Because it writes the information there before it goes into the database. If something goes wrong when it executes a query or something, it knows how to piece stuff together. Now, when it comes to backup situations and stuff, you can go crazy and start backing up transaction logs, because it might take a while to back up your whole database. So you do a full backup in the morning or in the night, and then you do incremental transaction log backups during the day, which basically captures the transactions, everything that has happened, so that if something goes bad and you need to restore a database from the most recent full backup plus the stuff that happened after that most recent full backup, those incremental, it is possible. However, it is a nightmare to do it. It is very, very difficult to get a point-in-time restore. I mean, it's. I don't think I've seen anyone actually do it. It's a good, IT loves it. Oh, it's cool. We need to have it, and DBAs loves it as well. But it's tricky to maintain. So good full backups of the database. That's the main thing you should do. And if you do rely on a nightly backup or a by daily backup of by twice a day or whatever, then I would recommend setting the recovery model to simple. We talk about it in the install guide because that way it won't have to record everything in that transaction log. And it can actually speed up things as well. A full recovery model means register and record every single thing that happens in this database, whether it's someone just scanning a table or whatever. And that means that transaction log will keep growing and growing and growing. And you often see running out of space because that transaction log is eating up everything because it stores all that information. It's supposed to truncate it and make it nice when you do backup or things, but you have to kind of constantly maintain it. It's very difficult. If you set it to simple, well, it's more simplified. It relies on the full backup for a restore. It won't write as much crap to that transaction log, keeping it nice and tidy. And when you back up the database and the transaction log, it kind of shrinks it for you and stuff. So if you see a growing transaction log, it's probably because the recovery model is set to full, which it is by default. Even TempDB, I think, is set to full. So set it over to simple if possible.
So if you have 5 vaults, you should have like 7 hard drives on your server, one for each vault and one for the OVM.
Well, yeah, you're reaching extreme things. I mean, I'm saying, these are things to consider. It doesn't mean, you have to split it up like that to begin with. No, but that gives you something to grow towards. If you're starting to see that your single setup with a single drive is showing signs of not being happy, then you want to consider moving them to separate drives. Not separate partitions, separate drives, if possible. And also take a look at what RAID it is. Some RAID can add a lot of overhead just because RAIDing is, writing data here, writing data there, spanning multiple physical disks into one device, etc., etc. But all that can add some overhead. And some RAID levels are much slower reading and writing than other RAID levels. So RAID can be a nightmare as well. 10 is probably the best one performance. It's also the most expensive RAID level where it mirrors data and also keeps back, but you have to have 4 disks for a single RAID 10 and it's stuff. So it's probably RAID 1 or 5. Stay away from 0 or anything else if you're dealing with RAID. Pre-sizing the database. Now, that can add some overhead as well. If the database needs to grow because more data is more files are put in, more values are put into the data card, that physical MDF file needs to grow to fit that information. And that growth spurt can, of course, take some resources. It has to kind of expand it a bit, and now expand it a bit more, expand it a bit more. while it's probably pretty fast, it still adds some overhead. So it is possible to actually set a fixed size for the database, i.e. not the top size, but okay, I know my database contains, right now 2 gigs of data. Set the database file to 3 gig or something like that. The outgrowth is, if it somehow reaches 3 gigs, it grows a little more to not kind of die. If you be aware with that maximum file size, it's usually set to some kind of crazy level, like 2 terabytes, which is why it's marked there. The restrict file growth, and 2 terabytes, you're never going to see a database that big. But if someone goes in there and says, my disk is 100 meg, so I'm going to set it to 100. That means SQL will stop writing to that database and operations will just start going down the drain. So don't restrict the size, but if possible, assign a size for the database that's more than the current data of it is. Again, outgrowth can have an overhead, which is bad. So instead, every now and then, as a maintenance task, check how much data that database file contains. If this physical file is 2 gigs, and you can right-click and select properties on the database, and you see that the actual data of it is 2 gigs, it's just going to keep outgrowing. So expand the physical file size now to 3 gigs or 4 gigs, so something that gives it space to grow. And there is also an auto shrink. It's a little option you can enable. It's not on by default, but make sure it is off, because if it now, that means it's going to keep the database file nice and tidy, but it constantly will start working to rearrange stuff and keep that small, and that's going to lead to an overhead as well. You don't want that. Darn it, am I running out of time again? 5 minutes, 8 minutes, this is no good. We need longer session. Okay, so we talked a little bit, where should you put your files then? Best ideal scenario is put the MDF, LDF transaction log. Keep them on separate systems or separate drives. It will actually help a lot. A single drive is not really ideal, and your server will end up with a single drive to begin with, unless you configure it otherwise. The temp DB, we talked a bunch of the temp DB, and the temp DB is very important and often overlooked when it comes to performance things. So take a look at that darn temp DB and make sure that it is not having a lot of read and write, because you usually leave it on the system disk, on the same drive as Windows is, and which is probably not the beefy RAID good drive that you put your database. So actually you could move then your temp DB over to that database file. If you only have a second drive for your Vault database, you might actually want to, and that's much faster than your system drive, your Windows drive, right? So you might actually want to move the temp DB to that other drive, ideally to its own drive. Yeah, exactly. Exactly. So here's some fancy pictures showing that this is, one drive, everything is here. SQL Server, has to read and write its stuff from it. Windows, temp DB, log files, on the, the database files, MDF. I don't think you'd ever see NDF. It's there. It's good to know that there could be a database. You could manage a database with an NDF. But let's say you have here, for example, there is still one drive, but it's RAIDed. RAID, for redundancy, for everything that's written to the first drive is written to the second drive, and nice and backup. If one goes down, the other takes over, and so forth. But you're still dealing with all the files on the same drive there. Now we're seeing here, now we're starting to split up there. So that's the first split that you probably want to aim towards. The data files on its own drive, the Windows operating system, and temp DB on its own drive. And then we get even more crazy here. Then we have three drives. That's the one I talked about there, right? You have your Windows and SQL Server, just the software essentially running. 5 minutes. And then you have all the important database drive on your good, speedy, reliable RAID drive, right? And now we can introduce a third drive and split it up, and you know, it just keeps going. Network, well, you know, network is actually network is important because all the clients and all the remote machines will have to talk to the SQL server, right? So it needs to have good and nice access to the SQL server. So that's also something to consider. Make sure that it is given a dedicated thing. Often on these servers, there is a lot of maintenance tasks and stuff happening over that same network connection. So it's starting to throttle the access that all the clients are given, which you don't often realize, but it could. So to give it dedicated network access if possible. Wow. Should have been in there. That looked like a fun thing, huh? Probably a pre-recorded clap. I think so. What is maintenance? Well, maintenance, that's a, you know, we talked a lot about the consideration, disks, blah, blah, blah. That's, you know, once you have that running, once your SQL server is up and running, you need to kind of maintain it, keep it happy during the thing. So we talked a little about that. The recovery model, we talked about that. There's even a crazy bulk log setting that's even more tricky. So if possible, keep it simple. That's my recommendation there. We talked a little about the backup models and stuff. This slide, again, is going to be available for download, so you can kind of read through it slow and not listen to me. What do you want to do every day? This is so important, and unfortunately, when you have your SQL server, you know, if you have a vault or plan to have an EPDM vault or manage a vault or whatever, make sure there is a darn backup going on there, right? Nightly backup. You have to make sure there is a backup. There's so many scenarios where, you know, customer calls up and say, our server, you know, went away. And then, okay, you know, set up a new one and let's restore the backup. What backup? We don't have a backup. I thought someone else put in a backup. You know, that was 2 years ago when they installed the server. So yeah, take an extra look. Make sure there is a backup. SQL Server comes with a maintenance and agent that can take the backups while the server is running in a nice and way. Of course, ideally, you probably would have some dedicated backup hardware, backup exec. There's tons of different good software solutions that can connect and back up to the database. Never back up the MDF and LDF file on their own. They are always held open for reading and writing by the SQL server. If you take those, it might be in the process of writing something to that transaction log, and you copy that to a backup device, you're going to have a hard time restoring that thing. So use proper SQL backup if possible. Rotating media. Don't use the same old hardware, media, tape, whatever. Then you realize year down the road that it's just been a bad media. Your backups that you take constantly cannot be recovered from it. So try to rotate it. That's another, it's just one of those, you should just do it if possible. Right? Don't store the backups on a drive on the same SQL server, right? Because if the SQL server goes down, your backups are gone as well. So try to get them away from it. Yep.
Another thing is to keep the archive database backed up at the same exact time.
That's always the tricky part, to get them synchronized. And, in an ideal world, no one would work in the vault at any point, and you have all the time you want, but there is no ideal world. So you have to do the best you can. Try to back. I mean, the physical files, they don't really change that much, so you could rely on a weekly complete thing and an incremental backup on the physical file. The SQL, you want to have a complete backup. You may, if disaster should happen and we actually have to go back to the most recent backup, well, first of all, hopefully you have a backup from the night before or something instead of from 4 months ago or a year ago, which has happened. So it's like, okay, they say, give us back our files now or all our information. Well, there was in that backup that you didn't take. You can't recreate that magically. So backup. But there will probably be a slight gap. It's not easy to have them one the relationship, to have them 100% the same since they're living, unless you're closing off the server, preventing people from accessing it. Oh, yeah, we're running out of time here. That's no fun. We'll keep on going. I don't know if there's anyone after this, but these slides and stuff will be available. Now, what do you want to? So everyday backup. That's the thing you want to take away from that. Every week, every month, maybe. Indexes. Indexes. We're not going to go into it, but indexes is something that SQL Server uses to quickly find information in a table. And those darn indexes, so it's kind of identifier. So you can quickly grab the information when requested from a client. There's tons of indexes that are applied by EPDM development on tables that require indexes. You could add your own indexes. We don't recommend it because now you're starting to fiddle around with the database and adding your own stuff. Indexes are good in some situations, bad in other situations. It all depends on what you add or read from that data. Yeah? No, it won't, but upgrade might drop tables and rearrange stuff. So there may be scenarios where unexpected things would happen, but not from an index. I would say no. But if you start doing constraints, you say that you create some views or something that rely on a certain table. We've seen that customer put in some extra stuff in the database, and all of a sudden they can't upgrade because the upgrade expects that table to be released stuff. Yeah, in that case you would have to do that. But if you do create your own stuff in it, let support know about it, right? Because often we find things like, what's that there? And they say, well, we don't know, but yeah, they know. They put stuff there. So don't put stuff there if you can't. Keep the indexes up. But the indexes that are there can actually become very fragmented because every time it adds data, removes data, especially if you do push in a lot of files, add a lot of files, it has to create these indexes and it starts becoming fragmented, like a hard drive can be fragmented where the information is not nice and concise, it's all over the place. So that's where we talk about a maintenance plan to rebuild or reorganize these indexes, making them a little speedier. And that's also an indication. If the server is slowly going worse, slower, it could be that indexes on certain tables are actually becoming a little jumbled up. So having a nice maintenance plan can help. Don't go overboard with rebuilding indexes, though. It all depends on the Vault usage and stuff. Do have it at least, once a month or something. Maybe more frequent, depending on how much is happening on that database. Keep an eye on those log files that they're not eating up all your disk space and stuff. Disk fragmentation itself, the drive itself may need a good defrag at some point, because it reads and writes to the physical drive, right? And quarterly tasks. That's also actually a good thing. It doesn't really have much with the performance, but test your backups. At some point, every few months, take the most recent backup, restore it on a test machine, not the production machine, to make sure that it can read the information, that it can actually access that should disaster happen. Maintenance plan, well, there is a nice little wizard where you can set up all this stuff, back up a database, check integrity. This is where you can set up a wizard or a maintenance task to reorganize or rebuild your indexes. And it's basically how long should it work on those indexes. Reorganize keeps the indexes where they are, but tries to fix the order of them. Rebuilding drops them and recreates them, which takes a little longer. But you would get a nice, more cleaner index set up with a rebuild, but it takes longer. So it's one of those. You probably want to do it during business hours. Back up the database, check the integrity. It's all there for you. Yeah, this is the indexes stuff we talked about, right? It normally, without an index, it goes from the top and start looking for the information. With an index, it knows that I can go here and grab it straight away instead of having to read through it. But sometimes reading through is better than going there. So indexes are not. Is there someone else on its way in, or? Yeah, anyway, they're just happy to be here. So sometimes performers take a look at those indexes. There are ways of checking the fragmentation, but that's a good first step. You know, when nothing else makes sense, it could be the indexes that are a little out of whack. Rebuild, reorganize. You know, it just describes what the two things are. Reorganize is a little faster. And I had a nice video, but I'm not going to show that. Activity monitor, this is more of the you know, keeping seeing what's wrong with the server. There is a pretty nice thing called activity monitor. That's probably, if you're having an issue and you have access to the SQL Server, the activity monitor is where you want to take a look, because it can tell you all the activity that's happening at that point. And you can sometimes pinpoint the workstation or the other server that's causing that load and causing everyone else to hang. And often that is, you know, some workstation is doing something really heavy that is using up all the power of the server. So all the other requests are being queued up and they can't really do stuff. They start, you know, it takes long, or they can't right click, or they can't log in or whatever. Take a look and see if there's something that's eating up all the CPU and what workstation it is. And you can find it, you can sort it by host and find the culprit. And maybe that tells you, okay, every time they check in this particular assembly, you know, it locks up the database. At least we know what operation it is and can try to figure out, is it a bug, is it something else, you know. Yeah, I'm not going to show that. Windows has a good performance monitor where you can keep an eye on the disk access, the disk reading and writing. And there's tons of counters and stuff. I would say Google it, because this is standard Windows stuff. Recommended counters to check for activity on your SQL server. Because it's going to tell you if your drive is crappy, or if it's constantly hitting that drive, reading that temp DB file. You know, that could be your bottleneck. Profiler is another tool that's pretty good, and we use it a lot in tech support. Sometimes when we can't reproduce an issue or need to kind of see the thing happening, there is something called SQL Profiler. You can set it. Profiler means it's basically going to record all the queries, all the operation that clients and other servers are doing to the database, and you can then save that file, and we can then open it on another machine and go through it and see if something is taking a lot of time, duration, a lot of CPU, find what operation in the vault is doing it, and try to figure out why that is happening. I'm not going to show that. And here it goes back. I already told you. This is the official statement on virtual stuff and NAS and SAN. It's basically, it will work. We can't really test all those combinations. And that's what I said. There's like 1 million combinations of virtual hosts out there, and you know, versions of each host, setups, and all this fancy stuff, you know, and storage combinations and hardware and shares. It's just a huge mess for SolidWorks to officially test every these combination. So should it turn out to be your virtual environment causing this, and we cannot reproduce it on a real physical machine or something, we're going to blame the virtual environment first and say, avoid, you know, move to a physical machine. So if you're considering going virtual, I would say don't. But, you know, again, this is basically a layover showing that, you know, there is the machine itself, but now you have the virtual stuff, and then you have the Windows stuff in the virtual, and there you have the SQL part, instead of getting good and nice direct access to your machine. SAN stuff, same thing there. If you're putting databases on a SAN device, which a lot of IT likes to do and stuff, and it's fancy, just keep in mind that there are tons of little configuration options. SAN can be horribly slow in some combinations. Put a lot of money into it, it's usually fast, but it can be slow, so don't overlook that. Physical, direct, attached disk rather than a SAN device, if possible. And slow disk access leads to overall performance problems. And we've seen tons of things, especially with SANs, that there are a lot of SAN-specific tools that's happening. SAN is usually shared by other staff, so it could be maintenance tasks and stuff that they're doing that kind of just slows down that disk to a crawl, and SQL Server gets hit by it. All these things can affect a SAN device. So the bottom line is avoid SAN if you can. And again, virtualization, there's nothing preventing you from doing it, but avoid it if you can. Oh, there we are. Ta-da! Very good. Sorry it was a little late, but oh well. It's almost theme park time, right?
One more boring class.
What did you say?
SAN storage, would you recommend avoiding that on the archive?
Actually, no. That would work pretty good there. Because again, I don't know if you were in my class. You were in the class yesterday, right? Yeah, but you see, it's just physical files being written and written. It's not that big of a deal, There, the SQL is more big of a deal because it reads and writes constantly to those database files. It reads to memory, but it also uses the transaction log and the temp DB and those things. So it's more important to give the dedication to the SQL server rather than the archive server. Which is also, you put your archives on a NAS device or but if it's really, really slow, your overall time to cache files will be slower since it has to read them from a slow device. So,
If I have multiple vaults, or 2 vaults, I'm doing better. So I'm managing 5 companies, and right now they have totally different data sets. So I was looking at bringing in 2 vaults. Would I get better performance by combining them into a single vault?
No, actually, you would get better performance by keeping them separate because it's less overall data, if that's a way, and it can be tricky to combine 2 vaults as well, unless you start from scratch. Right. I would say, keep them separate. Okay. I don't see any reason for that.
I've got a virtual archive server. We're running out of space. It's 2 terabyte right now.
Yeah.
I got to add more space to it. Am I better off adding space or adding a second drive to it?
Second drive.
Second drive?
Yeah.
More drives the better?
Yeah. Yeah, I mean, that's, I would say, I mean, we're talking about the archive, the physical archive files right now. So they're all stored on that single drive, right?
Right now, yes.
Yeah, so now, adding a second drive and then moving a few of those 0 to F folders to that drive, right?
You recommend moving the folders as well?
Well, yeah, because, it's still going to have to add more stuff to it, right?
Right.
So if they are still stuck on the first drive, it won't matter, right? Yeah. But that's, you can kind of cut it in half, right? You can move half of it to the new drive or 1/3 of it to the new drive.
Because I was thinking about just adding a second drive and then joining it. Right?
You could, but
it's at the same thing, basically the same thing as adding.
I would say you're probably going to gain more performance by having a second drive rather than expanding your existing drive. You actually will because, it's now going to start reading happily from 2 drives instead of one thing. So I would go there and
just more to manage.
Yeah, of course, like anything.
Okay, thanks, Dorf.
You were talking about having multiple hard drives. Or you think it's better just to have a single drive there, like a high-speed drive, or some RAID application for some RAID setup?
Ideally, not a single drive if you could. I mean, as a start, you usually.
A single drive for each one
Oh, you mean like that? Well, RAID is, redundancy. It's for backup purposes, kind of live backup. Should the first drive go, your second drive is probably there alive, unless the whole rack blows up, right? So that's the main thing for RAID. I think it's the redundant data, the writing of the data to two drives at the same time, keeping them in sync, right? One goes bad. If you have a single drive, that goes bad, it's bad. You have to go back to your backup. With a RAID, you might go. But RAID is more,
One for each database.
if possible, but if that's not possible, sure, one drive per thing is ideal. And then make sure you back up your database frequently.
I wanted to ask, you mentioned before that the SQL server has to be separate, but the archive server, you can put other things on it. Would you be able to, like an IIS server, like for a web service for EPDM, would that be okay to put on an archive server?
Yeah. The archive service is very, it doesn't really add that much overhead. It's a small service, doesn't take much memory. What it does is basically read and write stuff to those archives. And it doesn't use up much memory. It grows very little. SQL Server will eat up everything, right? So the less you run on the SQL Server, the better. That's why we recommend, if you're going to, separate them, dedicate SQL Server. Archive Server can be on a virtual machine or something that's not that important. It's usually not the bottleneck. The network, of course. Yeah. And that's another thing with virtual things. You're probably sharing the same kind of network throughput. All your hosts are essentially, everything is going into the same kind of physical network connection. They're rarely dedicated also. So that's another overhead you get with virtualization, I think.
Had a 2 quad gigabit load balancing network cards in their server.
Wow. That's pretty sweet. Quad gigabit. Sheesh. Yeah.
Presentations.
Exactly. What's my email? I forgot to put it up. It's my name. Tor, I wonder how you Tor Ivero, Torive. Here. I've got a bunch of business cards for people who want.
Okay.
There we go.
I can hit you on the forums too.
I'm going to keep an eye so that I don't give out on the other person.